So now we can go over our nomenclature on carboxylic acids. One of the things about nomenclature of carboxylic acids is that in general it's a little bit easier than other functional groups because we don't have to determine any numbering. And that's because the carboxylic acid carbon is always carbon number 1. So our numbering is defined for us, and then we don't need to put any of the numbering into the parent name because, again, we know the carboxylic acid is carbon number 1. So this being a 7-carbon chain is heptanoic acid. From there we can name our substituents: 2-bromo, 5-ethyl, 4-isopropyl, 3,3-dimethyl, heptanoic acid. We also need to put our chiral centers in, our stereochemistry. And this molecule has 2 chiral centers, and that's 2 and 4. Carbon 3 is not chiral because carbon 3 has 2 identical substituents, 2 methyl groups. Carbon 5 is also not chiral because it has 2 identical substituents as well, the 2 ethyl groups. So what do we have at carbons 2 and 4? Carbon 2, the bromine is highest priority. The carbon to the right, because it's attached to oxygen, is higher priority than the carbon to the left. Arrow goes counterclockwise, which is S, but our lowest priority group, the hydrogen, points forward, so we take the opposite, which is R. Same thing is going to be the case at carbon 4. Our hydrogen points forward, so we'll have to take the opposite. But what's highest priority? Highest priority is to the right because that's a carbon attached to 3 carbons. Up to the top is a carbon attached to 2 carbons, and the same thing to the left. So on those we have to go one further. And the hydrogens on the isopropyl group are lower priority than the extra methyl groups to the left. So 2, 3. Counterclockwise, again, we have to take the opposite, so 4R. Alright, number 2. Again, we can number it and then put in our substituents. We have 3-hydroxy, 2-isopropyl, 5-methyl, 4-oxo, octanoic acid. We need to do our chiral centers, which are at 2, 3, and 5. Carbon 3. We can see our arrow goes counterclockwise, but our low priority group, the hydrogen, points forward, so we take the opposite, so that's 3R. Over here at carbon 5, highest priority group is the carbonyl, second is the rest of the carbon chain, third is the methyl. Arrow goes counterclockwise, again have to take the opposite, is 5R. And finally at carbon 2, we have first priority, second, and third. Arrow goes counterclockwise, but because the low priority group, the hydrogen, points back, we keep it as is for 2S. Alright, number 3. Again, we can number this. And then we have 6-chloro, 7-hydroxy, 2,2-dimethyl heptanoic acid. Our only chiral center is at carbon 6, and it's going to be S. Because it's our only chiral center, and I'll put in the priorities here if you want to see them, because it's the only chiral center, we don't need a number in front of that S. All right, number 4. We have a 9-carbon chain that's going to be nonanoic acid. And I'm just going to list the substituents out here because there are a lot of them. 2-tert-butyl, 3-isobutyl, 4-sec-butyl, 5-isopropyl, and 6 and 7 have bromines. So we can put those in alphabetical order. 6,7-dibromo, 4-sec-butyl, 2-tert-butyl. Because remember, with sec-butyl and tert-butyl, those are both numerical, the sec and tert, so they get alphabetized under B and not under S or T. And we get our isobutyl and our isopropyl, and then our parent name, which needs to include the 2 alkenes at 6 and 7, so 6,7-dienoic acid. Alright, number 5. More of the same at this point. 7-bromo, 7-chloro, 2-mercapto, 6-oxo, hept, 4-enoic acid. And then for stereochemistry, we need 2. We need to worry about the alkene at 4, and then 7. So carbon 2 is S. And we'll put in the priorities here for you. Carbon 4 is E, and 7 is R. Finally, number 6. This is going to be Nona 2,6-dienoic acid. Again, we put in all of our substituents. 3-bromo, 2-chloro, 6,8-dihydroxy, 7-mercapto, 4-methyl. One important thing to note, it's really common to name that methyl as a substituent, But that methyl is not a substituent. That methyl is part of the parent chain. And so we want to be careful and make sure we realize that that methyl is part of the parent chain. How many stereocenters here? Well, 2 is an alkene, so we need E or Z. 4 is chiral. 6 is an alkene. And 8 is chiral. So we have 2E, 4S, 6E, and 8R. So at carbon 8, the oxygen is highest priority, the carbon bonded to sulfur is second, and the methyl is third priority. At carbon 4, the carbon bonded to bromine is highest priority, followed by carbon bonded to oxygen and methyl.